All right. I said that sedimentary rocks were my favorite. They can tell us the most about the environment that they formed in. So we're going to keep talking about them. So everything from here on out is going to be about sedimentary rocks, the stratigraphic sedimentary record. Now, environments of deposition on the previous map, remember I said all of those orange parts of the map were where sedimentary rocks had deposited. But notice that the orange wasn't all over the world, right? There were just specific parts of the world. There was a lot of them, but there were still specific parts of the world where that sediment deposited. And we call those depositional environments, right? Anywhere where sedimentary rocks can deposit, or sediment can deposit and sedimentary rocks can form. Now, there's all sorts of different sedimentary environments, right? Such as a lake, a lagoon, a shallow marine, mountains, deep marine, so on and so on. And every single one of them will accumulate different types of sediment. So for example, anywhere where there's a lot of really high transport energy, right? Like maybe water is moving really, really fast, like in a river up in a steep mountain, you're going to get a lot of really large rocks. And this is because that high transport energy will very easily wash away the smaller pebbles, right? So in these high energy environments like rivers, you're going to get boulders, big cobbles, things like that. On the other hand, in very low energy environments where the water just kind of sits around, it's not flowing very quickly, maybe a lake, that's going to be the only environment where really fine grains of sediment can deposit, right? Nothing is moving it away. It finally is able to deposit. So it's going to be a really muddy depositional environment, right? So lakes, other stagnant environments, those are the ones where you can finally get that mud, silt, and clay, the really fine material to deposit. So just by looking at the grain size, you know the energy of the environment. You can also look at the color. Again, I'm going to tell you again, color is often the worst way to identify a rock. However, there are some colors that are important in sedimentary rocks. Two of those colors being black and red. If you see a black sedimentary rock, especially if it is very fine grained, right, made of like mud and things like that, you can assume two things. You can assume one, that there's an abundance of organic matter. There's a lot of live things, a lot of plants and animals. And two, you can assume that there wasn't very much oxygen. Right, so this rock has a fossil of a fish and that rock is black. Well, I can assume that there was a lot of organics there and there wasn't very much oxygen. So maybe it was like at the bottom of a stagnant swamp or something like that. Now, the other color I said was important was red. And when you see red, it often means that the iron within the rock has oxidized, or in other words, has rusted. Right? And this happens when iron, two iron atoms combine with 3 oxygen atoms to form ferric iron oxide. All right, so just know that if there's iron in the rock and it comes into contact with oxygen, it can rust or oxidize. And this can turn the rock red or even brown or purple or sometimes pale green. And so if you see a red rock, you can assume that that rock was in contact with the atmosphere, with oxygen. If you don't see that red, you can assume that like maybe if it's a black rock, I said before, it was away from the atmosphere, away from oxygen. All right, so not just the color of the sedimentary rock is important, the size, the shape, and the arrangement of the sedimentary grains is also very important, if not actually probably more important. Now, as sediment is transported from source to sink, and sediment moves because of gravity, so the source is often the mountain, and then it's transported downhill, and the sink is often the depositional environment down near the coast. Okay, the size, the shape, and the sorting of the sediment grains changes. Really high up in the mountain, you're going to get really large grains. Those grains are going to be really jagged, and they're going to be poorly sorted, meaning that you have a lot of large grains, but also a lot of small grains mixed in there. As those particles are transported along that pathway by a river or wind or just gravity, maybe even ice like a glacier, those grains are going to be worn down and smoothed down. So they're going to become smaller, they're going to become more well-rounded, and they're going to become better sorted, meaning they're going to be sorted in with like grains, right? So that's why the sand on our beaches is all pretty much the exact same size, right? Because it's been well sorted, it's far away from the source, the mountains. So here's a figure that I love where you can see the different grain sizes, grain rounding, grain sorting, to help you get an idea of what I mean by, angular or rounded, poorly sorted, well sorted. So we've talked about the color, we've talked about the size, shape, and sorting. We can also talk about the overall structures within the sedimentary rock, because those structures can record, again, the type of environment that that sedimentary rock was formed in. So for example, if you see mud cracks on a sedimentary rock, well, you can assume that it used to be wet mud that dried out to become hardened mud cracks, right? So maybe it used to be a lake that dried out or something like that. If you see cross-bedding, this is when you see lots of layers that meet each other at different angles, right? We call that cross-beds. And cross-beds are often formed in environments where the direction of transport changes over time. So think of like a sand dune at the beach. Those are formed by wind, and wind changes direction every so often, right? Every day, every season, every year. And so you get cross-bedding within the sand dune. If you see graded bedding, this is when the bottom of the rock has very large grains, and that slowly transitions into just small grains up at the top of the rock. We call this graded bedding. And this happens when, often when water transports sediment downhill and then deposits the sediment all at once, so that the large grains settle out first, followed by the small grains settle out slowly on top of them. So this happens a lot in water, deep marine environments. And finally, this is one of my favorites. You can see ripple marks. And anytime you see ripple marks on a rock, you can assume that there was either water or wind on top of that rock. If there was water or wind moving in both directions, like maybe in the intertidal zone where waves are going back and forth, then those ripples are going to be very symmetric. Or if you are in an area where that wind or water is going pretty much in just one direction, maybe like a river, then those ripples are going to be asymmetric. I just went on a hike up in North Carolina to Hanging Rock. And on that hike, as we were going over the rocky steps, I looked down and I actually saw ripple marks in those rocks. And it was so cool to see that the rocks that I was standing on that were millions of years old still preserved those river and coastal environments that it was formed in. So keep a lookout next time you go on a hike for those ripple marks.